All right, welcome. In this explainer, we're going to look at how ancient minds tackled absolutely huge problems. And they didn't do it with fancy tools, but with something way more powerful, pure logic. It's a story that kicks off with a simple question, and one of the most famous structures in the world.
So let's start with a puzzle that seems completely impossible, right? We're going back over 2,500 years. You're standing there at the base of this massive, colossal pyramid. You have no laser, no measuring tape, nothing. How in the world could you figure out its true height?
Well, the guy who took on this incredible challenge was a thinker named Thales. He was from a bustling port city called Miletus, and because he was from a merchant family, he traveled all over the place. He soaked up knowledge from ancient civilizations like Babylon, Persia, and, most importantly for our story, Egypt.
Now, when the Egyptians asked Thales how tall the pyramid was, they were probably just expecting a really good guess, an estimation. But what Thales had in mind was something totally revolutionary.
He said, "I will not estimate it, I will measure it." I mean, just think about that statement. It was a game changer. Thales wasn't just being clever, he was signaling this fundamental shift in thinking, away from guesswork and toward the power of mathematics to find a precise, concrete answer.
So how did he do it? His method is it's so simple and so brilliant. Okay, first, he lies down in the sand to make an imprint of his own body. Then he stands up at one end of it. And then he just waits. He's waiting for one very specific moment, the exact point in the day when his own shadow is precisely the same length as his body imprint. That right there is the key.
And this is where the geometric genius comes in. See, the sun's rays are hitting both Thales and the pyramid at the very same angle. This creates two triangles that have the exact same proportions, what mathematicians call similar triangles. So when Thales' shadow equals his height, the two shorter sides of his triangle are equal. And because the pyramid's triangle has those same proportions, its two shorter sides must also be equal, which means at that one perfect moment, the length of the pyramid's shadow is its exact height. It's so elegant and it's foolproof.
But Thales didn't stop with pyramids. This guy was on a roll. He applied the same powerful logic to solve another really critical problem. But this time, it was back home on the coast of Miletus, which was a huge hub for sea trade.
Think about it. For sailors and merchants, knowing how far away ships were was vital for trade, for defense, for everything. But how do you measure a distance that you can't possibly walk across? Well, Thales, being Thales, came up with a clever device to solve this exact puzzle.
This is another brilliant use of geometry. From up high on a tower, Thales would use his little device to create a specific angle pointing right at the ship. Then he'd just turn around and replicate that exact same angle, but this time pointing at the land. By doing this, he created a second identical triangle, what we call congruent triangles. And because the triangles are identical, the distance he could easily measure on the ground was now guaranteed to be the same as the impossible-to-reach distance to the ship. Just amazing.
Now, these incredible solutions weren't just clever parlor tricks. They were practical uses of universal rules of geometry, rules that Thales was one of the very first people to actually sit down and formally prove. He was literally creating the foundation for all of Western mathematics.
To really get his impact, you have to place him in time. We're talking about the 6th century BC. He wasn't just a mathematician, he was really one of the founders of Western science and philosophy. He even famously predicted a solar eclipse, which just goes to show you how much he wanted to understand the universe through rational, logical principles.
He really gave us a whole toolkit of fundamental truths. He proved that vertical angles are always equal. He proved that the base angles of an isosceles triangle are equal, which, by the way, was a key piece of information for his pyramid measurement, and that a triangle's angles always add up to 180 degrees. These weren't just abstract ideas. They were the reliable, unchanging building blocks he used to make sense of the real world. So, in the end, Thales' greatest contribution wasn't just the list of theorems. It was a completely new way of looking at and understanding the entire world.
He helped kickstart this massive shift in human thought. Before him, the world was mostly explained through myths and stories about the gods. Reality was something you kind of guessed at. Thales came along and showed that the world was a rational place, that it was governed by consistent rules, and that through logic and geometry, its biggest mysteries could be measured and truly known.
And that legacy, it is absolutely everywhere today. It's in the GPS that guides your car, which uses triangulation. It's in the architecture of our tallest skyscrapers and our longest bridges. It's even in the computer graphics that create our movies and video games. Thales proved that a simple, elegant idea, like the properties of a triangle, could give us the power to measure the immeasurable. And that leaves us with a pretty cool question to think about. What other simple truths are hiding out there in plain sight, just waiting for us to see them?